There's some incredible science hiding in plain sight, and a lot of it is right in your kitchen. Today, we're going to uncover the secret chemistry behind some of our favorite foods, starting with a question you've probably thought about before.
Seriously, have you ever noticed this? Maybe you're helping out during a festival, making that amazing, sweet, sticky syrup, the chashni for gulab jamun, and you see that when you add sugar to water, it doesn't just make it taste sweet, it actually changes the water itself. It's a fantastic little kitchen mystery, and today we're going to solve it.
Okay, so our first clue to solving this mystery lies with a really special group in chemistry. I like to call it the Particle Counting Club. And this club has one very simple rule. It doesn't care what kind of particle you are. You could be sugar, you could be salt, whatever. It only cares about how many of you there are. It's all about numbers.
And here's the official scientific name for our club: colligative properties. It sounds a bit complicated, right? But it's really just a fancy way of saying exactly what we just talked about. These are properties that only depend on the number of particles you dissolve, not what those particles actually are. So whether it's the sugar in your chashni or the salt in your dal, it's the quantity, not the quality, that changes things.
So, this Particle Counting Club has 4 main members. Each one is a super interesting story. You've got the lowering of vapor pressure, the elevation in boiling point. Aha! That sounds like a big clue for our chashni problem, doesn't it? Then there's depression in freezing point and osmotic pressure. Today, we're going to focus on that very first member, because if we understand that one, everything else clicks into place.
All right, let's dive into our first investigation. We need to understand something I call the Great Vapor Escape. This is all about a fundamental concept called vapor pressure, and trust me, it is the key to solving our entire mystery.
To make this super simple, just picture a pot of water. But instead of water, imagine every single H2O molecule is a person in a super crowded room. Now, some of these people, especially the ones right near the exit, which is the surface of the water, have enough energy to just escape. They break free and turn into vapor. That push, that urge to escape, is what we call vapor pressure. It's literally their escape energy.
Now this is where it gets really interesting. On the left, you've got pure water. The surface is just water molecules. The exit is clear. It's an easy escape, so the vapor pressure is high. But look at the right. When you add sugar, those bigger, heavier sugar particles don't really want to escape. Instead, they just hang out near the surface, kind of blocking the way. The exit is now crowded, making it way harder for the water molecules to get out.
And this right here, this is just a formal, scientific way of saying what we just figured out with our analogy. When you add a non-volatile solute, that's our sugar, to a volatile solvent, that's our water, the vapor pressure, the escape energy, goes down. Simple as that. The exit gets crowded.
So we get the what and the why now, right? It just makes sense. But science loves to be precise. It's not just about knowing that it happens, but by how much. And for that, we need to decode a secret formula. It's called Raoult's law.
And here it is. Now, I know, it looks a little mathy. But don't worry, every single part of this equation tells a piece of our story. It's this beautiful little code that connects the drop in escape energy directly to how much stuff you've added. So let's crack it open. All right, let's crack this code together. That P with the little zero, P naught, that's our before picture. It's the escape energy of pure water when the exit is wide open. Then there's PS. That's our after picture with the sugar water and the crowded exit. The top part, the difference between them, is just how much the pressure dropped. And that whole chunk on the left side is what we call the relative lowering. It basically tells us how big the traffic jam at the exit is compared to when it was empty.
Okay, so mystery solved. Adding sugar crowds the exit, lowers the vapor pressure, and that changes how the chashni boils. But you might be thinking, all right, cool kitchen fact, why does this matter outside of making sweets? Well, this is where things go from the kitchen to a real chemistry lab, and it gets even more amazing.
Because here's the kicker. This whole effect is so incredibly predictable and reliable that scientists have turned it into a powerful detective tool. By just measuring how much that vapor pressure drops, they can actually figure out the identity of a completely unknown substance. No kidding.
And this is the ultimate tool for our detective work. This formula comes straight from Raoult's law. But look closely. You see that M2 hiding in there? That is the grand prize. It stands for the molecular mass of the solute, the thing you dissolved.
and molecular mass is like a unique chemical fingerprint for every substance. This equation lets us find that fingerprint just by weighing some stuff and measuring a change in pressure.
So, let's just quickly meet the new players in this formula. W2 is simply the weight of the mystery stuff you added. W1 is the weight of the water you dissolved it in. We already know M1, that's the molecular mass of water. So the only thing left that we don't know is M2, that chemical fingerprint we're looking for.
So check out how a scientist would actually do this. It's a beautifully simple process, almost like a recipe. First, you take a pure liquid and measure its escape energy, P0. Next, you dissolve a very precise amount of your mystery powder in it. Then you measure the new, lower escape energy, P-sus. And finally, you just plug all those numbers you measured into our ultimate formula. And boom, it spits out the value for M2. Just like that, you figured out what your unknown substance is.
So there you have it. We went from the sweet syrup in a gulab jamun all the way to a powerful method for identifying unknown chemicals in a lab. And it all came down to one simple idea: particles crowding an exit. So the next time you're in the kitchen, look around, pay attention, because now you know the science is everywhere, just waiting to be discovered. What mystery are you going to solve next?